Oh, hey, so we're going to get started with today's little topic, the quotient rule. Our friends, the seven dwarfs, are going to help us out as we move through this. Instead, if I make it full screen, maybe it's a little better. So, quotient rule. Ready? Begin. Here it is, the quotient rule. You have this printed on your paper, and it's a bear. So the derivative of the f of x over the g of x, so top, a rational expression, something over something, we're going to take the denominator and multiply it by the derivative of the numerator. From that, we're going to subtract the numerator multiplied by the derivative of the denominator, and then we're going to plot all of that over the denominator squared, okay, which is just a lot to keep track of, a lot of information to go with, and we want to be able to make that work a little bit better. So here's where the screen disappears. Here's where the seven dwarfs are going to come in to help us out with this particular thing. Probably just done that, got rid of it. All right, so what we're going to think of is we're going to think of it as high and ho. So high is the top part, ho is the bottom part. We're going to try to get a pen. All right, so clearly that's not going to work. And get a pen, we're going to use blue. Okay, so the derivative of high over ho. High is my numerator, ho is my denominator. High, ho, think seven dwarfs on the bottom. So what it's going to be is ho d high minus high d ho all over ho ho, okay, or ho squared. Okay, so ho d high minus high d ho over ho ho, and it makes a difference in this case the order that we do these things. So it really is important that we have ho d high minus high d ho over ho ho. Notice we've got all the ho's right in the row at the end, ho ho ho. So think Santa Claus, think the seven dwarfs, whatever it takes out. So we're talking about ho, we're talking about the bottom, that's the g of x, this is ho. And the f prime is d high, the derivative of the top part. And then this is high, and then d ho, which is the derivative of the bottom part, and then all over ho ho, or ho squared is probably how we'll write it. Okay? So let's see if we can't make it work out. All right? I think I have a cheater version of it right here. So we want to work that in there. It's much easier to remember than the product. The other thing, it may seem a little goofy at first, but live with it. Okay? So we want the derivative. The derivative, ho d high. So ho is the bottom part, 2x plus 5. D high is the derivative of this, 6x plus 7. Minus high, that's this 3x squared plus 7x. D ho, which in this case is 2, all over ho ho, which we're just going to write as 2x plus 5 squared, quantity squared. Okay? So there we did. We did ho d high minus high d ho all over ho ho. So it'd be great if we were done now, but we can't leave that. That's ugly. It doesn't really help us with the derivative. Doesn't give them an expression. So we're going to extend a little bit. We need to simplify this top. We don't want to leave things laying around. So we're going to do the FOIL thing. 12x squared. Inside I've got 30, outside I've got 14, so I'm going to go with 44x plus 35 minus, going to distribute 6x squared minus 14x. Okay, so there's lots of places sign errors run rampant in these sort of problems. And we're just going to leave the denominator here because there's going to come a time when we're going to want to know when the denominator is equal to 0 perhaps. So where the function would be undefined or where the derivative would be undefined. So when we get there, it's easier in this case to be able to tell when that's going to be. I'm going to go just a little further, one step. Combining my like terms, I've got 12x squared minus 6x squared, so I think that's 6x squared, and then plus 30x. The whole other debacle the other day with 11 or 9. Trying to be careful. 2x plus 5 squared. That's my derivative of this thing. So that talks about how this function changes. If I wanted to know the instantaneous rate of change anytime along through, plug in the number, bingo. I want to find out when it's undefined, when this is equal to 0. Find out where we have a horizontal tangent, this thing's equal to 0. Okay? Ho d high minus high d ho over ho ho, that's the thing we want to get in line with. All right, so what's the derivative of tangent? Hopefully, maybe, by now you remember, or you're starting to remember, that the derivative of tangent is secant squared of x. Okay. The other thing that we know is that the tangent is equal to the sine divided by the cosine. So we're going to go about this the long way with our derivative piece to get there. I'm going to try to go full screen. Where's that? Let's see if I can't make this work. Gives me a little more space. So, y primed, ho, d high, derivative of sine is cosine, minus high, d ho, derivative of, oops, this is x here, derivative of cosine is negative sine, all over ho ho. Okay, and I write it that way instead of cosine of x squared. Cosine squared is what we're doing because we're squaring the cosine, not squaring the x. It makes it more clear. So what I've got up top is I've got y primed equals cosine squared of x minus, oops, negative sine squared, so let's make it plus sine squared of x all over cosine squared of x. Okay, how many people want to cancel those cosines out? No, no, no. No one does. Great. How many people remember what the cosine squared plus the sine squared adds up to? Cosine squared plus sine squared, or sine squared plus cosine squared is 1. So we end up with 1 over the cosine squared. How many people remember what the reciprocal of cosine is? If you're thinking we've got to get to secant squared, so it must be secant squared, it is. Remember, they all pair up with the cofunction. All these pieces that I've been asking you to remember, kind of get churning into your brain. You got to be thinking about how they work, how they connect with each other, what the connections are, big picture stuff. Okay, so you can just remember that the derivative of tangent is secant squared, but I wanted to use the product or the quotient rule to make that happen. Do one more. Let's see, or you want to do this one yourself? You do? All right. So we'll check on this one in the morning. Okay, and we'll move right along. I'll tell you what. I'll make it a little easier for you. I'll do the hard part. There you go. Okay, you take care of this part and the simplify, and we'll check in with what you get for the numerator for later on. Good deal? Great. Okay. All right, so we can move on to higher order derivatives. So pause the video, do that one. Higher order derivatives. So we've got this big giant problem right here. We want to know the first derivative. We know our rules, so we can just, happily write some stuff down and be on our way. Okay, that's the first derivative. Then there's the second derivative. Second derivative is the derivative of the first derivative, and it's the rate of change of the rate of change. So we just take another derivative. 20x cubed plus 72x squared minus 48x plus 24. Remember, the derivative of the constant is 0, so that goes away. And then we could get to a third derivative, which would be, I guess, the rate of change of the rate of change of the rate of change. So that would be 60x squared plus 144x minus 48, and we could keep going at least a couple more times to get this down to fourth, fifth derivative. We typically spend our time on the first derivative and the second derivative. The first derivative tells us something. The second derivative tells us something. Third derivative is just for fun. Fourth, fifth, sixth, however many you have. I guess we'd have to go through like 5 derivatives to get down to nothing. 5 or 6. 6 would get us there. So, okay, higher order derivatives just means we keep taking derivatives again. Okay, and remember, if we have to rewrite, differentiate, simplify, or if we have to use the product rule or the quotient rule to get a second derivative, we do. Alrighty? Now, position. Okay, that's, I think, what we call it, the h of t or something like that, or the s of t or whatever, v of t, and acceleration. Okay, so v of t is h primed. Velocity is the position, derivative of position. Acceleration is v primed, derivative of velocity. It's also the second derivative of position. That's really all I've got to say about that. Okay, so again, if you know the position function, which we did the other day with young Mr. Pfeiffer, you know the velocity, you can get the velocity function, you can get the acceleration function. I think that's all. Flash ahead to there. I should put a vanity card. I think I'll start doing that. And not let you see it, except for if you pause. That's the work we're going to do. There's flashes of a couple quizzes upcoming, which we'll talk about or have talked about. Okay, quotient rule, ho-de high minus hi-de ho over ho-ho. That's really about all there is. You've just got to get that. That's another one that you want to get into your brain, like the first times the derivative of the second plus the second times the derivative of the first. The product rule, you want to have the derivatives of all the trig functions, all of that stuff. That's what we need as we move forward. 9 minutes, 55 seconds. I'm going to stop this in exactly 10 minutes. Hope you enjoyed. Hope you learned something. We'll see you tomorrow.